Hey guys, welcome back. So today we're working on this EMGLO air compressor. It is powered by a Honda GX140 and is rated at 5 horsepower. Now, from looking at the machine, it has had a very tough life. That said, it is very well built. So my hope is that we can get this back up and running again. But somebody kind of gave up on it. Actually, this was thrown away. My friend Jason pulled it out of the trash, and I can kind of see why. I did try pulling the engine over, and unfortunately, the engine stuck. Or potentially the compressor. They're actually connected with a belt. So, my hope today is that we can get this back up and running again and compressing air. So let me get you set up a little bit better and get going on this. I want to start by removing the belt that connects these two. And it looks like to open this up, we do need to remove a clip on each side. That said, though, I don't think it's going to be quite that easy because we do have this piece right here that's connected over to the head on the air compressor. So likely we're going to have to remove one of those bolts and potentially this fitting as well. So let's start with the easy stuff and we'll remove what we need to get the access we need. It was actually kind of loose. So I'd say someone was in here at some point. All right, let's see if this did anything for us. Yeah, the right side's free. Definitely a well-built machine. I mean, just look at the size of this pulley. Pretty well-built piece. Anyway, the normal direction of rotation is counterclockwise. So if I try to spin this counterclockwise, it does not move. Let's try the other way. And it did move. Now it's moving quite freely. And right there, it's getting stuck. And I actually hear kind of a noise here in the top end of the engine. So yeah, I think the engine is our problem, which may not be a bad thing. I actually recently fixed a Honda clone, which I think has the same shaft. So I'm getting a little ahead of myself, but I'm thinking, one way or another, this compressor will spin again. So to get the belt off, I do need to loosen this bolt as well as all 4 bolts on the compressor, and we can slide it to the right, which will give us a bit of slack. But I'm thinking, since we know, or at least I think that it is the engine, I'm going to leave this alone for right now. I'm thinking let's pull the spark plug and the valve cover and see if that gives us any clues as to why the engine won't rotate. Let's get the air filter out of the way. It's the wrong one for the engine, although it might have still made a seal. Anyway, let's get the plug out. Just going to blow that out. There is a bit of debris down there. Well, the plug spins out by hand, so that is a good sign. Although it does have a bit of resistance in spots. Plug doesn't look too bad. I mean, there's no rust. A bit of carbon, but nothing concerning. So let's try rotating the engine now that the plug's out, and no. Oh, it is rotating now. Interesting. It did hit a hard stop, but then it pushed right through and actually continues to push right through. So I wonder if we had a stuck valve potentially. We have compression. So yeah, the engine may not actually be bad, but let's take the valve cover off anyway. We'll check the valves, check the clearance, and just see what kind of condition they're in. Those are also fairly loose. So someone has gone through this at some point. Yeah. Looks like we have some RTV and no rust. But yeah, a bunch of RTV. And the oil, at least what I can see from it, it's pretty dark. But I don't see any actual physical problems here in the valves. So let's just rotate the engine, make sure they're both moving properly. And if they are, then I don't think the issue is up here. So the valves, I don't think of the issue. Both are opening and closing just fine. You know, even the exhaust valve, I see it getting bumped during the compression stroke, which tells me the decompression system is also working fine. And the more I think about it, the more I think it wasn't the valves, because if it was just a stuck valve, then I would have been able to turn the engine backwards, and I couldn't do that. You know, it was stuck in both directions. But, you know, even when it did start to rotate, it was coming to a very hard and abrupt stop. You know, it almost sounded like metal on metal, which is a bit of a concern, but potentially there could have been a little surface rust as well in that cylinder, and maybe it's cleared out. So I'm thinking for now, you know, I'm just going to put a little bit of Marvel mystery oil down the cylinder. You know, we'll check the valves real quick, close this back up, and then I think we're going to move on to getting the belt off. I want to isolate these two for now, and then we'll focus in on the engine. We'll try to get it to run. Once that's running, we'll shift our attention to the compressor. So I'm just going to soak this down in the Marvel Mystery Oil. And I think when I try running this for the first time, I'm also going to use some two-stroke fuel. You know, just in case it was that piston that was locking up. So I've got the engine rotated to top dead center. And actually, let me show you the process, because some people don't realize this, but the piston actually comes up to the top twice. So the way you can tell is by watching the valves. You know, right now the exhaust is open, so that means the piston's coming up, pushing out the exhaust. And now the intake valve opens, so the piston's going down. Now if I back it up, the piston's at the top right there, but you can see we're in valve overlap, and you don't want to set the valve clearance there because both of these are more or less at zero clearance right now. So you want to keep rotating until the intake closes, the exhaust gets bumped for the compression release, and right about there, the piston's at the top, and I can see by looking in the spark plug hole that we just passed top dead center by a tiny bit, which is fine. So to check the valves, you should look up the specs. I did not look up the specs on this engine, but most Hondas, you know, 4,000ths on the intake, 6 on the exhaust is pretty good, and that can be plus or minus 1,000th without issue. So I'm going to start with a 6,000ths feeler gauge, and that feels pretty good actually. It has drag. We'll try a 7. A 7 doesn't fit. So the exhaust valve actually is perfect. Let's check the intake. Let's start with the 4000s on the intake. Yeah, actually it fits with a fair amount of drag, but it does fit. So the valves, they are actually pretty much dead on. For now, I'm going to get the valve cover back on. I do need a new gasket or some more RTV. I'm thinking for now, I'm just going to likely order a gasket once we get to that point. We still don't know if this engine's going to run properly. So until we do, we'll just bolt it on. Worst case, we'll drip a little bit of oil until we get the new gasket. To slide the compressor out of the way, I did disconnect this main line going to the tank, as well as this other little line up here. But now that it's disconnected, I can test for compression, and hopefully you can hear that. But we have good compression coming out of that compressor. Yeah, I'm noticing this cap is not threaded all the way in, and it actually does not look like a Honda cap. But we do have oil, and actually very clean. So I think someone did change this recently. Could stand a little bit more in there, but there's plenty in there. We're in the safe zone. So yeah, that just doesn't thread in right. So I do have another Honda clone engine actually right behind me that I can steal that dipstick for now so we can get a good seal. And yeah, that dipstick did not thread into the Honda clone, but let's see if the Honda clone one threads into here. Yeah. So that's the way it's supposed to be. So we're going to have to order a new dipstick for sure. Let's just make sure the throttle plate moves, and it does. This is the throttle control right here, and that does not move. So, that might be by design, but I'm thinking, it would be good if we could at least start it not at full speed. So I'm going to loosen up this nut right here. That should allow us to bring the speed down to an idle. Yeah, and that's all it was. So there's nothing wrong with it. They just set it as a fixed throttle. But like this, we can take the spring tension off the governor, and the carb should idle the engine. Now, I'm sure the carb is likely gummed up. So let's get that off next and take a look. Yeah, it looks like the fuel valve was left in the on position, which is not great. And that just highlights the fact, too, that when I pull the carb off, there's going to be no fuel valve left holding the fuel back, if there's any in the tank. So let's take a look here. see what we see, which is a bit of rust on the cap. Tank is mostly empty. There is some rust, definitely some debris, but I think that can be saved. So yeah, let's pull the carb, but we'll get the tank off at the same time. Yeah, throw of that carb looks pretty bad. I'm actually surprised the choke and the throttle plate move. Got this little plug. So what do you think? Is this one going to be any good? Oh, it's a Honda, so it might be. But the thing that occurs to me too is that, you know, this likely was outdoors after it was thrown away. And this is the filter that was on it. There was no bolt holding it down, no air box to cover it up. So if it did rain, then rain would have gone down into the carb and probably the engine. So I'm thinking there might have just been some rust on the cylinder walls holding that engine still. And that bolt did not look good, so this carb might be a total loss, but at least, I was going to say, at least the bolts are coming out fairly easily. But definitely a lot of junk and sludge on them. Yeah, doesn't look great. That is water that came out. This stuff, it's definitely rust, but I think there is some varnish in there too, so potentially this will clean up. Now, as far as the carb itself goes, it actually looks decent. Pin is not stuck. Needle's not stuck and looks good. Let's see if we can get the sediment bowl out. Yep. A lot of junk in there. Let's get the pilot jet out. As bad as this carb looks, it is coming apart pretty easily. Let's see if the same is true for the main jet. Yep. It's the main jet. Surprisingly not plugged. The emulsion tube moved a little bit. And there it is. Yeah, definitely some debris. And those little holes kind of look clogged. So let's go through everything. We'll just make sure the passages are open. For this, I think I'm going to use the Dremel, try to knock some of the heavy stuff off, and then we'll just give this an extra dose of degreaser, let it soak for a bit in the ultrasonic. Yeah, pilot's open, not plugged. The emulsion tube, this one doesn't have too many holes, but there are a few. And if they were blocked, they were only just. And for the main jet, I like to use these micro drill bits. I'm not trying to drill it out, but I'm just trying to find the biggest one that'll still fit, which in this case is a 72, but we're missing the 71. And I'm thinking that's the right size, so I do have another kit here that has the 71. And 71 does not go through, but it's not metal on metal. It was just some plaque. So now the 71 goes through. And even the next size here, the 70, doesn't go through, but when I spin the jet on the drill, I don't feel metal on metal. It just feels like the drill bit is kind of digging into, varnish and plaque. So I'm actually going to put this in a pin vise and just spin it a little. Yeah, you can see that does go through pretty easily. So it is just some plaque there on the sides. But I think I'm going to stop there. If I go any further, I am going to take some material off of that jet. And I'm going to open up this valve as well and just disassemble it. Yeah, likely there is a blockage in there, just given what we see in the bowl. And that is not fitting very well. Nope, let me get a different screwdriver. A spring washer, the valve, and yeah, it's definitely clogged up. You can see the passage right there looks like it's blocked. Yeah, there's a ton of mud in there. So I'm not sure where that passage leads, but wherever it goes, it's blocked. And I would say that's likely the feed over into the carb. So yeah, let me spray in there, see if it comes out anywhere. But based on what I'm seeing, I'm thinking it's not gonna. Okay. So the passage from the needle over to the sediment bowl, that is clear. And then we have the fuel, which comes in right here. Yeah, and that's what's blocked. Yeah, nothing's getting through. So let me grab a small little zip tie. I find those work well because they can bend around the corner, and you can just kind of poke at the blockage until it breaks up. Then you can use carb spray to blow it out. So we're making it pretty far. Let's check. Nope, nothing yet. So the zip tie works well for corners, and it actually went down pretty far, but it didn't clear the blockage. So I'm thinking if we use a drill bit and spin it, the flutes on the drill bit will dig out that stuff. And you can see we actually just pulled that right out of there. So we'll just do this a little bit. I might go back to the zip tie, some carb spray, and eventually we'll get it. Not yet. Yeah, so the zip tie wasn't cutting it. It was going down very far, but it wasn't really poking through the end. So instead, I am using this piece of stainless steel wire to try to poke through. And I think I may have just done that. So let me see. Yep. Okay, we've got flow. It's actually cleaning up. So I don't think it's rust, or if it is, it's very light rust. It's always surprising to see what carbs clean up and which ones don't. You know, this one I did not give much of a chance, especially the bowl. It was in really bad shape. But in this condition, I'd say that is perfectly usable. Carb body also cleaned up quite well, although the inside doesn't look quite as good. You know, there is some corrosion in there, but I don't think that's going to impact the way that it runs. Yeah, I think this is going to run it halfway decent. So let's get it back together, starting with the emulsion tube and the main jet. And we'll get the needle and float in next. All right, that should be good. And the bowl drain, not sure if that's a gasket there or not. Yeah, I think we're missing the gasket for the bowl drain. So let me dig around. I'm sure I have a spare that we can throw on in its place. Yeah, this part's carb has a bowl drain with a gasket. So I'm just going to steal the gasket. We'll stick with the OEM bolt. All right, let's put the sediment bowl next. And then the fuel valve. So I did take this piece out. So we'll just get it back like that. The actual valve, the spring washer, then the plate. Okay, good. The valve works. I also forgot to pull this needle out before cleaning the carb and the ultrasonic. So I pulled it out after, just sprayed through it with some carb spray, made sure it was clear. This one was only 1 1/4 turns out, which isn't a lot. You know, usually they're at least 1 1/2 or 2 turns out. So I think I'm going to start with 1 1/2. There's 1 1/2. And that just leaves us with the pilot jet. And this machine does actually idle. So usually on a generator, I say just turn it through until about a thread or 2 comes through. In this case, we actually want to set the idle speed. So I gave it a few extra turns. That still may not be enough. So likely we're going to have to fine tune that. But for now, you know, this carb is done. So let's actually get the tank off. Then we'll get this reinstalled and try it out. To get the tank out of the way, I do need to remove that bolt right there, and I can't do that with this throttle bracket in its way. So I am actually going to thread the spark plug in first because I need to remove this bolt as well as that bolt. And this one, if it gets away from me, it's likely going to go right into the cylinder. So we've got two nuts holding on to the tank, but we do have an extra bracket right here as well. This is actually, looks like an air-powered solenoid that pushes against the governor arm to slow it down. So when the tank builds pressure, this plunger deploys, slowing the engine down. And that only happens when the tank is full. Once the pressure drops, that solenoid retracts and the engine returns to full speed. We are free. The airbox, it is pretty dirty, but I am not going to clean it up because we are going to have to replace it. There's just too many parts missing. But we are going to use it for now because it is a spacer for these nuts. Without it, we can't really tighten the carb down. It's good to see the fuel going in so fast. So that blockage is gone. Hopefully the needle kicks in before we flood over. And I'm getting a little concerned because it is taking quite a bit. But it is slowing down. I think we're good. So I'm going to get this wire plugged back into the spark plug. I think we're ready for contact. So I am a little nervous about this one. The engine, it was locked up pretty good. And even when it started to rotate, it wouldn't rotate fully. It would hit a very hard stop. it sounded like metal on metal. And if it should lock up while running, that's it. The engine, it'll be done. But hopefully it won't. We do have a bunch of Marvel Mystery Oil in there, so that is going to create a lot of smoke. And I'm also using 2-stroke fuel, so that also has some oil in it. But that'll give it the best chance possible. So let's turn the ignition on, the choke's already on, and the fuel valve's on. Let's give it a try. Not too bad. I was kind of expecting the worst on this one. The engine was stuck, and when it started to rotate, I didn't like what I heard and felt. That said, though, this thing started first pull. It ran quite well, nice and smooth, quiet, and surprisingly, almost no smoke. Given the amount of oil that was in there, I fully expected it to smoke like a freight train, and instead, this engine is running extremely well. So I dare say the engine might actually be good. So let's set this aside for now. Let's focus in on the compressor. We'll check that out. And assuming we like what we see there, we'll put the belt back on and give this thing a try. As far as the pump goes, we did spin it earlier. It spins freely and it is moving air. So I don't suspect we're going to have an issue with the pump. As far as the oil goes, it does take a specialized synthetic oil, which is not cheap, and unfortunately I don't have any. There is some oil in there, but it's kind of on the low side. So this is something we should drain out and top off, but until I know that everything works, I'm just going to run with what we have. We need to get the belt back on, this pipe back on, as well as the one up here that I took off, and resecure the idle solenoid. Both the solenoid and actually the valve up here are supplied with air from this pilot valve. This, when the tank is fully pressurized, will divert air into these two pipes, slowing the engine down. And this one, I believe, holds the intake closed. So the pump essentially becomes ineffective and the tank stops building pressure. The rest of these connections look pretty good. We have the emergency relief right there, which is not stuck, tank pressure, and a valve to close off the flow from the tank, which is missing the knob. So if we don't get any flow out, we might need to open that up. As far as the filter dryer goes, it is loose, so we do need to fix that. And the regulator seems to move, so that likely works. Now, the regulator had a 3/8 inch fitting, and actually all my airline is 1/4 inch, so I did pull this out, and I'm going to swap it out for a 1/4 inch. So Yeah, let's get started. We'll get this stuff all back together and give it a try. This is the head bolt right here that was holding the protective guard in place. So I do need to retorque that. The manual I found said between 10 and 12 foot-pounds. So we'll tighten that up, and then I'm just going to double check the others and make sure they're good. Oh, there is a bolt, or I should say a nut, on the bottom side. So I'm just going to clean up these threads a little bit. Looks like there might be some Teflon in there. And we'll put some fresh stuff in and see if we can get it to actually tighten up. All right, you missed it, but I didn't hit record. Anyway, I got some Teflon on this fitting. It's snugged up, but it still feels a little loose, so that could still be an issue. Right now, I'm putting on this adapter just to change that 3/8 down to 1/4 inch NPT. I think we're pretty much ready to go. I did top off the fuel, still using 2-stroke, and all these connections are secure. The belt is tensioned, so theoretically we should build pressure, assuming the pump works and nothing is leaking. Now, I am going to keep a close eye on the gauge. I don't know what these tanks are rated at. These labels are pretty faded, but most compressors, they're good for at least 120 PSI, if not a bit higher. So, if we kind of go past the 120 and it doesn't look like we're slowing down, I might shut it down a little bit prematurely. But my hope is that at some point this pilot valve will kick in, the engine will idle down, and the tank will stop building pressure. And assuming we get to that point, we'll try it out. I did connect this over to the lift pump. So right now, we don't have any pressure. And with any luck, after running this for a minute or so, this should be able to lift itself. So let's give it a try. Choke on, ignition's on. Low idle just kicked in, right around 130. And it looks like things have stabilized as far as the air pressure goes. So let's try the lift table. There we go. Ran out of gas. So, pretty good test, although I do hear an air leak, and I feel it. Yeah, we got a pretty good leak right there on the copper tubing. And potentially one down here. It's actually hard to tell because it's blowing right on this line, but it doesn't look like it's seated very well. So yeah, we got one, maybe two leaks, but other than that, I think things are looking pretty good. So I'm going to let the system bleed down, and then we'll take a closer look at these two leaks. I guess before we're completely out of pressure, let's test the regulator. So I turn it clockwise, and that's pretty much it. So clockwise must be full pressure. There we go. So the regulator does work. Good. Yeah, definitely leaking down there as well. Smaller leak, not like this one. So it looks like the compression fitting has everything it needs to function properly. But it was definitely not on straight, so that might have had something to do with the leak. Anyway, I'm going to cut maybe the bottom part off here, maybe the bottom ½ inch. We'll fit it with some new fittings. We'll try to tighten it back down, and I think this leak will be fixed. All right, that I think will be good. Let's try fixing that big pipe now. I picked up a new piece of copper tubing, and the goal here is to make this look something like that. Now, this is soft copper. It is fairly easy to bend. The problem is the tube will collapse. So you just can't bend it. What we need to do is actually fill it with sand. So I'm going to crimp one end off. We'll fill this entire thing with sand, crimp the other end off, and then we'll start bending until we get something that will work on this machine. Now, you don't have to crimp this. You could probably use some duct tape. But we have extra tubing, so I'm not too worried about wasting a little bit here on the end. I think that'll do. And it's important that there's no air pockets in there, so just by tapping it like this, it should kind of force the sand or allow the sand to go to the bottom of the pipe. Okay, and we are, I was going to say we're full, but not quite. After tapping it, it dropped about an inch. So we'll just add a little bit more. think that'll do. I'm going to use the tire changer to bend the pipe around. It's about the right diameter so that we can kind of match what we had on this old pipe. So I'm just going to get rid of this hardware since we don't need it. And then we need to make one loop and then go another 90 degrees. That'll do. So I'm just going to cut off the ends. We'll get the sand out. We're going to have to do a final cut on this. But for now, we'll just get it close. So the alignment isn't too bad other than the fact we're too tall. So I did measure it already. We are too tall by about 4 inches. So I'm going to start conservative, just take off 3.5, and we'll see what that gets us. Yeah, I like that. You know, we're still too tall by about a 1/4 inch, but once we add the flare down there, it's going to drop down a bit. Plus, we can just kind of massage this loop a little bit to get this to work. So I'm going to add the flare nuts. We will flare both ends, and then I think we can get this connected as it should be. Let's make sure the flare nut goes down. Yeah, I think that'll work. Let's test fit it and see how we made out. Yeah, that's going to work out really well. So let's cut the other flare nut off the old pipe. We'll put that on first, because once we add the flare, you can't put it on after the fact. All right, let's get the engine started again and build some pressure. We'll check for leaks. All right, let's give this a try. I am refueled. Ignition's turned on, the choke's on. Well, I was about to declare victory because the repaired pipes, they no longer leak. But now that these aren't making so much noise, leaking, I can tell we do have another problem. You know, at first I thought it was the pilot valve that was leaking, but actually it's the tank. You can see right down there, we do have a leak, unfortunately, on that tank. So yeah, although we have a good compressor and we have a good engine, you know, the tank, it's not good. It's tempting to try to repair this tank. You know, the leak here on the right isn't that big. And if that were the only leak, maybe it would be worthwhile. But that actually is the smaller leak. There is a much larger leak here on the left side. So yeah, unfortunately, you know, I think the tanks are shot. You know, these tanks do accumulate water and you're supposed to drain it out, Otherwise, they're going to rot from the inside out. And unfortunately, I think that's what happened here. Although the tank is shot, we do have a good Honda GX140 and a very good high-end compressor. So likely these can be used on something else. But both of these need a bit of work. They are incomplete and they are due for some maintenance. So I'm thinking before we call this one done, let's bring the engine and the compressor back to where they should be. So I'm thinking let's start with the compressor. We'll just change the oil and get a filter installed. Well, it's a few days later, and after draining the oil, I realized my mistake. The oil that I had ordered online, I thought had arrived, but when I went to go find it, I couldn't because it was delayed by a few days. So it is a few days later. We have the oil we need, as well as the rest of the parts to finish this thing up. And my friend Jason stopped by, bringing a few things to fix, and he also asked if I needed a tank. And as luck would have it, it's exactly the same tank that came off of this machine, although it's in much better condition externally. And more importantly, it is nearly perfect on the inside. So yeah, let's get the compressor finished up, then we'll move on and finish the engine up. And surprisingly, this takes a full quart of oil. And this compressor oil is blue. The stuff that came out was red. Now, according to the Jenny manual, they don't list any other options for this compressor other than the Jenny Ultimate Blue, which I'm sure you can use others, but it would have been nice if they had kind of steered me in the right direction, because a quart of this oil, I think it was about $33. And actually, I'd say it takes less than a quart, because it's looking like it might be at the full mark. Yeah, it looks like we're right at the bottom thread, which is right at the full mark. So yeah, it took quite a bit less than a quart. I'd say closer to about 8 ounces. So I'm going to eliminate, I think, this elbow. The replacement filter I got, it is smaller, and most pictures I see of this compressor actually has the filter coming out the side without this. So I think someone may have added this at some point to get maybe the needed clearance between the belt guard and the filter, but I don't think we need it anymore. And I'm just going to face this down in case someone leaves it out in the rain, which is likely to happen. Even though the oil looked pretty clean, I'm going to swap it out with some fresh stuff. I'm not sure what weight is in there, so we'll put some 1030 synthetic in, and I also got a new dipstick, so we get that swapped out as well. And that oil looks milky, so there was water in that engine. Which I guess we knew, since the engine was stuck. I got a new dipstick to replace the bad one that was in there, but I don't really trust it. It seems a little bit flimsy, and as we've seen in the past, this can actually cause engine problems, and it's not needed. You just fill it to the last thread. So I'm going to take a proactive measure here and just get rid of it instead of waiting for it to break and start floating around inside the engine. That should be good. I'm just going to hit it with some compressed air to blow some of those little bits out. But I think with a new gasket, that should seal. Going to shine this tank up to the extent possible. And we also need to replace this right here. This barb is just plastic and it is snapped right off. So I do have an extra, but let's get the tank cleaned up. And actually there's a little fuel in there too. We'll drain that out and put the new barb in. And in case you're wondering, this is Goof Off. It's adhesive gunk remover. And it works really well for cleaning stuff like this. Also does a great job on plastic. I ended up pulling the governor linkage off just to give me a little bit better room here. Now this line, it is thicker than what Hondas typically use. So I'm not sure I'm going to get away with this. But it's worth a try. I'd rather use something like this because the actual OEM line is quite a bit thinner, the walls. These aftermarket air boxes, they're pretty cheap. You really need a metal washer to prevent damage to the cover. But as cheap as they are, it's a lot better than no air box at all. So that right there is the idle position. When I pull this towards me, it stops. And what you want to do is extend the solenoid all the way. While holding it in that position, you slide the bracket over and then tighten it down. Now, I'm not going to tighten it yet because what I'm noticing though is that this lever is almost rubbing right now on this bracket. And when I tighten it up, it's really close. So we might have to put a washer in there, but let's try it like this. And now that we have everything together, I do want to try it one more time just to make sure that all the components I added work well together. The big difference though this time is that we're not going to build any pressure. I pulled the fitting from the regulator, and really at this point we know the tanks are bad, but I just want to make sure that this stuff is 100%. Well, guys, I think that's pretty much a wrap. This engine, it's running quite well, consistently starting first pull, and it sounds really good. And the compressor has no issues either. So although the tank has failed, these two items can be used on just about anything and definitely worth saving. So I'm glad I brought them back to 100%. Granted, I did waste a little bit of time making this tube, but even that was not a complete waste. I have very little experience making flare fittings and pretty much zero experience bending copper, and I was pretty happy with the way that turned out until I found the problem with the tank. Either way, we did save some equipment from the trash, and this stuff will definitely be put to work on something else in the future. So I hope this video helps someone. Thanks for watching.